This week we're going to focus on variation, and when I say that, I'm talking about how one variable varies with regards to another. So in these two illustrations, we're talking x's and y. So as x gets larger, in this particular case, you can see y is also getting larger, getting bigger and bigger. Over here on our second example, as x increases, you can see y is starting to decrease. So the three types of variations, as you can see, are direct, inverse, and joint. There is a fourth one we'll talk about later in the video, but these are the three big ones. And with each of these variations comes along an equation that's going to help us solve these types of problems. For direct, we'll use x's and y's, but the equation we're going to use for direct is y equals k times x. Inverse is going to be y equals k over x. You can see that in our first example with direct we are multiplying, and then in our second inverse we are dividing, which should make sense because multiplication and division are inverses of one another. So that might be a nice way to help remember those equations. And then joint is y equals k times x and then times z. Now with joint, we implemented a third variable. We could actually implement a fourth or fifth, so we can go times a times b, however many variables that we're going to use. But joint is essentially just direct variation with multiple variables. As you can see in each one of these equations, there's a k, which we call the constant of variation. So this is a typical variation problem that you might come across. It says y varies directly as x equals 3 when y equals 12, find y when x is 12. Now these are the steps to solving these types of variation problems. We want to first identify the type of variation and which equation we're going to use. Then we're going to plug in for known values and solve for that constant of variation, that k. And then we're going to use the constant of variation in one of the known variables to solve for the unknown variable. So let's use these steps to solve that equation or that question that we just saw. So step one was to identify the type of variation in an equation. So I always like to circle, underline the type of variation we're going to use. And it will tell you right in the problem. So in this case, it's direct. So we're going to be using that y equals k times x, since y varies directly as x. Now we're going to plug in for our known values and solve for our constant of variation. So you can see that they gave us essentially two pieces of information. We have x is 3 when y is 12, so we have both variables there. And then we also have this piece where we're given one of the variables and we're asked to find the other. So if we know we're varying directly, we're using y equals k times x. That second step says we want to plug in for our variables, our known variables, to solve for our constant of variation. So we know that y is 12 when x is 3. So by dividing both sides by 3, my constant of variation is 4. So for this particular problem, we now know that it is y equals 4 times x. Our last step is using the constant of variation that we just found and the other known variable. We're going to find that unknown variable. So we do know it is y equals 4 times x. So find y when x is 12. So we're going to plug in 12 for x, and we get y equals 48. Here's another one. It says m varies inversely as n. So if my variation type is inverse, m equals k over n. Now I'm going to plug in for m and n to solve for this k. We have been given that m is 2 when n is 6, so we know our constant variation is 12. We can see that by multiplying both sides by 6. So now we have this, y equals 12, oh, not y, let's keep consistent with the variables. Sorry about that. We have m equals 12 over n. So now we're going to find m when n is 3. So m equals 12 over 3. So m is going to be 4. In this example, we see that we have a joint variation. So it says z varies jointly as x and y. So that's how I'm going to write that out, and those are being multiplied. We're given this piece of information when x is 3 and y is 2, and then it occurs when z is 12. So I'm going to plug that in. So 12 is z. We don't know k yet, but that's what we're trying to solve. But we do know when z is 12, x is 3, and y is 2. So we're going to solve for our constant variation. And divide both sides by 6. So k ends up being 2. So for this particular problem, we know that z varies jointly with a constant variation of 2. Now we're going to find z when x is 4 and y is 5. So z equals 2, saying x is 4 and y is 5. So that's 2 times 4, 8 times 5 is 40. Our other variation is a combination of what we've talked about, and it's called a combined variation. And our formula for that is y equals k times x over z. And obviously these variables can differ depending on the problem, but you can see that we have a direct variation with x and an inverse variation with y. So it's a combined direct and inverse, hence the name combined variation. So in this problem it says y varies directly as x, so y equals k times x, but inversely as z, so we're going to divide by z. It says y is 24 when x is 48 and z is 4, so we're going to plug those in. So y is 24 when x is 48 and z is 4. So 24 equals, well, 48 divided by 4 is 12. So dividing both sides by 12, we get k to be 2. So we now know that our equation is y equals 2 times x over z. And we're going to then plug in this information to solve for, in this case, for x. So find x when y is 44. We don't know what x is, but we do know that z is 6. Well, 2 over 6 can simplify to 1/3. So after multiplying both sides by 3, three times 44 would give us 132. So x would be 132.